Anyway, so we'll just wait the others. So we'll wait 2 more minutes. So you guys can have a break for 2 minutes. Right, so while we're waiting for the others, do you guys have a question or clarification?
None, sir.
Wala po.
None, sir.
All right. So again, if you guys have a question, so feel free to ask me anytime. Ay, lamig naman dito sa Baguio. Oops. All right, so it's ready for 15. Are you guys already there?
Yes po.
Yes, sir.
So may we continue now our discussion?
Yes, sir.
All right,
Sige.
so are we good on this one now? On this slide? So don't you guys have a question on this slide?
Yes, sir.
Okay, so again, my advice here is memorize this formula. Okay. All right, so let's have an example. So arithmetic summation example, number 1. So evaluate the following using arithmetic summation. So as you can see right here, we have a summation from 20 to 103 with this formula, 5 times I minus 3. Okay, so this I here is your term, or your, let's see, if you're going to start with 20, this is your 20th term, or first term, actually. And then 21 here is your second term, and so on and so forth until you'll reach the 103. Okay, and then just keep on adding all of those. Okay, and then you will get the summation, or the total summation for this notation. Okay, so here we have the solution. Okay, so you can start with this one, and then you can actually bring out this one on the other side. So as you can see, we have here the 5 now, okay, times the summation from 20 to 103. So the remaining one is I minus 3. And then the second here is, it's like multiplying this 5 on this equation, okay, and then separating the 3 or minus 3 or minus 5 minus 3 on the other side. Okay, so as you can see, this one is quite confusing when it comes to forming a final formula when it comes to getting the summation. Okay, so don't worry, we have another way of doing this one. Okay, so for now we'll use this one since this one is like the fastest method. Actually, this one is the shortcut method. Okay, so just substitute the corresponding values or corresponding formulas. So 5 is this one, 5. And then the summation here is your range, which is from 20 to 103. Okay. So how did we get this 84? It is this formula, n minus m plus 1. Okay. So as you can see, 103 minus 20 plus 1 is equal to 84. Okay. So once you will see this one summation, that's the range which is equivalent with this formula, n minus m plus 1. Okay, so that's how we've got the value of 84. So are we clear so far for this one? And how did you get the 84? So guys,
Yes, sir.
so we are now on this part, okay? So this is the 5 and then this is the 84. And then now we are now in I. So what is this I? Okay, so this one is actually the average. Okay, n minus m divided by 2. I'm sorry, n plus m divided by 2. Okay, so where did this I came from? This one. Okay, so the range and then the average. Oops, n plus m divided by 2. So your n here is your upper limit, and then m here is your lower limit, and then divided by 2. Okay, and then minus 5 times 3. Okay, actually supposedly times 84 first, but since in here is 3, then actually it's fine. Okay, you can interchange those since they are a product summation. Okay, and then nothing will change anyway. So 5 times 3 times 84, or 5 times 84 times 3. Okay, so again, the summation is your 84, which is your n minus m plus 1. Okay, and then just do the math. Okay, so use your calculator, of course. Then you will get 24,570. Okay, so from 20 to 103, using this formula, you will get a total of 24,570. So did you guys get this one so far?
Not that
Medyo
much, sir.
Not that much. Okay, so anyway, we have another solution. Okay, which is the solution number 2. Okay, so you can use this one, but you have to memorize 2 formulas instead of memorizing this one. Okay, so for the first formula, you have to memorize this one. Okay. A sub n is equal to a sub 1. I hope you guys can see this one. This one is quite small. So a sub n is equal to a sub 1 plus times n minus 1 times t. Okay. All right. So the first thing that you need to do here is you have to know, okay, the first term, okay, by putting your lower limit or your first term into your formula. So 5 times 20 minus 3 is equal to 85. Okay. And then actually this one is already fine. Okay, as long as you know the first term, then you can now proceed in doing this one. But actually no, sorry. You have to know at least 2 terms. Okay, not just the first term, because in here we have to know what is the difference, or what are the difference from the first term to second term, from the second term to third term, and so on and so forth. Okay, so in here, keep on substituting the second term, which is 21. So 5 times 21 minus 3 is equal to 90. And then the third term here is 5 times 22, yeah, 22 minus 3 is equal to 95, and so on and so forth, up to the last one. So I put here a sub n because I don't know yet, okay, what is the term of the last term, which is 103. Okay, so just put here 103 minus 3. So 100 times 5 is equal to 500. So from here, we already know the first 3 terms and then the last term. Okay, So once you're done in having this one, say first two terms and then the last term, then you can now proceed in applying this formula. Okay, so this formula is a formula on how to identify how many terms in total on this range. So substitute your corresponding values. So your A sub 1 is 85, and then your letter D here is the difference. So as you can see, 90 minus 85 is 5. 95 minus 90 is 5. So we put here 5. And then just simply distribute this one. So 5 times n times negative 5, which is now this one. Okay, and then just simplify this one. So your A sub n here is 500. And then just keep on simplifying this one. So 85 minus 5 is 80. And then just transpose this one on the other side. So 500 minus 80 is equal to 420. Okay. And then your goal here is to get the value of n. So your n here is the total terms in this range, which is from 20 to 103. So as you can see, 420 divided by 5 is 84. So once you have already know the total terms in this range, then you can now proceed in applying this formula. So this formula is another way of getting the summation. Okay. Oops. So n divided by 2 times a sub 1 plus a sub n. Okay. So your n here is 84 divided by 2 times a sub 1 is 85, and then a sub n is 500. And then just do the math, and then you will get 24,570, which is the same with the first solution. Okay, so you can use this one or this one. So it's up to you. So did you guys understand this one?
Sir, saan nakuha yung 500?
500 from here, your upper limit. So just substitute this upper limit on this formula. So 103
Sige, sir.
is 3, then you'll get 500. This one is actually the A sub 84. Okay, this is the last term. Any other question or clarification?
Wala po.
All right. So if you guys do not have a question anymore, then you may now proceed in answering seat work number 3 once you're done in understanding those examples. Okay, so for seat work number 3, evaluate the following using arithmetic summation formula. Okay, so ranging from 25 to 50, and then 2 to 8. And then here's the given formula. Okay. So basically, you can do it manually, especially the number 2, but do not do that one. Okay, so that is why we are trying to learn the formulas, so that let's say there's a range of from 50 to 5,000. Then if you will do that one manually, then it will maybe take you 2 days, okay, or maybe just 1 day if you will do it continuously. But it's a hassle. Okay, so instead of doing that one, you can use these formulas instead to solve such summation. Okay. So are we clear so far for your seat work number 3?
Yes, sir.
So again, you can do this one handwritten or via Microsoft Word. Okay. All right. So the next one here is geometric summation formula. So this one is actually similar with summation, but a different formula. Okay. So as you can see, this one is geometric. So supposedly this one is notation, but we can derive this using a summation formula. Okay, but instead of a sub I, okay, we have here a times r raised to I. Okay, so that's their difference. So if it's a sub I, then that one is summation. Okay, but if it's a times r raised to I, then this one is geometric summation or geometric sum. Okay, then since we're using this symbol, of course, the operator here is plus. Okay, and then as you can see right here, we will start with 0. Okay, and we have this formula, which is just the same with this one. Okay, so a times r raised to n plus 1 minus a divided by r minus 1. Okay, so let's have an example for you to be able to appreciate what is this geometric sum. So evaluate the following using geometric summation formula. So we have here from 0 to 13. And then we have this a times r raised to I. Okay, a here is 1, and then your r here is 2, and then your I here is still your I. So here's the solution. So you can apply this formula for you to be able to get the geometric sum of this one. So again, your a here is 1, and then your r here is 2 raised to I. Okay, so just substitute your corresponding values using this formula. So a is 1, so you can actually remove that 1 since nothing will happen just by multiplying it to 1. And then your 2 here is your r, and then raised to 14. So where this 14 came from? So this is the n plus 1. So n here is 13, and then plus 1, so you got here 14. And then minus a, so again, your a here is 1, so minus 1, divided by r minus 1. So r here is 2, your a here is 1, so 2 minus 1. So if you're going to simplify this one, so as you can see, 2 minus 1 is 1. So we can have this simpler expression instead. Okay, so 2 raised to 14 minus 1. So use your calculator, okay, to solve this one, and then you will get 16,383. Okay, so for the summation, you have two options to memorize. So it's either those two formulas or this one. And for geometric summation, only one, which is this formula, a times r raised to n plus 1 minus a divided by r minus 1. So did you guys get this one? And how did we get 16,383?
Yes, sir.
All right, is there anyone who's confused? All right, so I guess none since no one is speaking. Anyway, the next one here is still with geometric sequence. So as you can see, a sub I is for summation, and then a times r raised to I is for geometric summation. Okay, so a here is the first term, and then I here is your starting point. Okay, so this is just another example. So what is a and r in the geometric sequence? So by using this formula, okay, so what is your a in here, and then what is your r? Okay. Can you guys guess? Anyone? Do we have a volunteer who wants to answer this example? What is our a, and then what is our r? Anyone? All right, so since no one is speaking, then I will call someone. Could you please answer this one, Miss Mr. Geneza Elmer.
Sir.
Okay, so what is the value of our letter A on this sequence? Can you answer this, Mr. Geneza, or no? It's okay if you will say no. All right, so anyone?
Sir?
Sir.
What is the value of our
Okay.
A?
Sir, A is 2, R is 1.
A is 2. Okay, this is actually a bonus already. So as you can see, A is the first term when I starts at 0. Okay, so as you can see, 2 is the result. So there's no other solution or formula for this one. Okay, just whatever is the value of this one, then that is already your A. Okay, and then R in the geometric sequence here is depending on the formula. Okay, so let's see. According from Mr. Labsan, this one is 1. So 2 times 1 raised to 0 is 1, 2 times 2. Okay. How about if it's 2? So 2 ones. No. Okay. So R here is not 1. Why? Because if this one is already 1, take note your starting point here is 0. So if this one is 0, then any number that is raised to 0 is 1. So 1 raised to 0 is 1 times 2 is 2, which is correct. But for the second term, which is now, let's say this one is 1. So 1 raised to 1 is still 1 times 2, but it's not 2 anymore. The result here is 6. So R here is not
Equal to
1.
2, sir.
Yes?
Sir,
R
R
is
is
equal
3.
R is
Okay.
equal to 3. So as you can see, in here, it's just like basically a multiplier. Okay, so 2 times 3 is equal to 6. 6 times 3 is equal to 18. And then 80 times 3 is equal to 54. So I guess it's kind of magulo, okay, since I'm not showing any solutions. But let me show this example for you to be able to get this one. So 2, 6, 18, 54, and then 162. Okay, so using this formula, okay, so we already know that a sub 0 is equal to 2. And then we've just assumed for now that the multiplier to get a sub 1 is 3. Okay, so 2 times 3 is equal to 6. So prove on the following equation. So using the recursive formula, okay, so we will know what is the next sequence. So for the first value, we have here 2. And then for the second value or second term, which is a sub 1 is 6. And then the third term, which is the a sub 2 is 18. Okay, so as you can see, whatever is your I here is the same with your I on your exponent. Okay, a sub 2, 2. A sub 3, 3. A sub 4, 4. Okay, and then just solve this one. So 2 times 3 raised to 4 is equal to 162. And so on and so forth. Okay, so from here we have proven that your A here is 2, and then R here is 3. Okay, so did you guys understand this one now?
Yes, sir.
All right, so again, if you guys have a question, feel free to ask. So, well, that is only if you are really listening, because if you are not listening, then you won't be able to ask any questions since you're now left behind, okay, or you're now lost. Okay, so once you're done in understanding those example and concepts for geometric sequence and summations sequences, then you may now start in answering this one. Sorry. So this one is only geometric sequences, not summation sequences. Okay, so in here, there's only two numbers. So the same with our past example. So identify the value of A and then R. Okay, and then just show the formula and then the provings solutions, just like this one, for you to prove that the R here is really, let's say 3, 4, or 5, okay, depending on the solution, okay, or on your proving equation. So in here, I've just used recursive uh, formula. So it's up to you. If you can come up with another kind of formula, then it's also okay. So yeah, letter A is already a bonus. So the hard part here is the letter R. Actually, you can answer this one less than 5 minutes. All right. So are we clear so far for the seat break number 4?
Yes po.
Okay. How about the others? Do you guys have a question or clarification? So I'm only hearing Mr. Lapsan and Miss Garcia, Mr. Awas, and then Mr. Catores. Then the others, I'm not hearing your voices anymore. And also Miss Sumo. So she's also uh, responding. Okay. So are we clear on this one?
Yes, sir.
Talaga si
Yes.
Mr. Aantok to eh. Okay, so
Yeah.
that's good, Mr. Donato. Okay. So I rarely hear your voices. Okay. Anyway, so we have here the double summation and then the seat break number 5. Okay, so for double summation, this one is super easy. So the same concept with single summation. Okay, so all you do is follow these steps. So initially, you will be given with this kind of format. So that's why it's called double summation. Okay, and of course they have their own range. So for this one, we have from I to its maximum limit, and then we have the j to its maximum limit. So 1 to 4 and then 1 to 3. So what we did in here is distribute, okay, the letter j first, okay. So the j here is 1 plus 2 plus 3, okay. So it's like basically multiplying the I times 1 plus I. Let me just use my notepad. So it's like initially like this, I times 1 plus 2 plus 3. Okay. And then as you can see, we've just distribute this I inside the parentheses. That's why we have now this I plus 2I plus 3I. And then, as you can see, we have simplified this one further. So just add everything since they have the same variables. So it's now a total of or equals to 6I. Okay, and then the same pattern. So we have here the 6 and then the I. So again, what is your I? Those are your terms. Okay, and then we're using summation, so it should be plus. So your I here now is 1 to 4. So 1 plus 2 plus 3 plus 4. Okay, and then just do the math. Okay, just solve that one, you will get a total of 60. So the same with your seat break number 5. So evaluate the double summation, just like this one, the first step, and then the second step, and then finally getting the total value of that summation. Right? So this one is super easy. So you can do this one again, handwritten or via Microsoft Word. Same with seat break number 4. handwritten or via Microsoft Word. So are we clear so far regarding with the double summation?
Yes, sir.
Yes,
Yes,
sir.
sir.
Yes, sir.
All right. So let's now move on to the last topic, which is strings. So this one is a sequences of letters or other symbols written without commas. So the shortest way uh, of explaining this one is with the comparison of sequences and then sets. So as you can see, in sets they are separated with commas. The same with sequences, they are separated with commas. But for strings, just remove the comma and then that's it already. Okay, so this one is a sequence. Okay, so how did I say that this one is a sequence? Because this one is not inside the close and open bracket or curly bracket. Okay, so if it's not inside a curly bracket, then that one is just a sequence. But if it's inside a curly bracket, then that one is a set. And then for the string, this is the string. Just simply remove the comma. Okay. The same with this one. This one is a sequence. Just simply remove the comma, and then you will get the string right away. All right. So string here is a set corresponding to a sequence. Okay, basically. So it is a set of all distinct elements in a sequence. Okay. So at the same time, in string we follow the sequence. Okay, or the proper arrangement. So we have here the set, we have here the sequence, and then if you're going to add one more, which is for the string, then just remove the comma. We'll get 149, 16, 25. Okay, that is the string format for those sets and then sequence. So the same with this one. This is the set, and then this is the sequence. Sorry, this one is actually already the string. Okay, so if you want to transform this one into a sequence, then you have to put comma. All right. So again, take note that in sequence, the order of the elements is important. Okay, so as I've mentioned many times. And then in set, the elements order is insignificant. As we have mentioned in our past topics for the module 1 and module 2. Okay. All right. So give three different sequences that have these elements, okay, as corresponding set. So anyone who can give three different sequences for the number 3? Okay. So I have a direct message here from Mr. Ryan Roger. So we have YXZ, okay? But this one should not be enclosed with the curly bracket. Why? Because we are only asking for the sequence, okay? If it's inside the curly bracket, then that one is already a set, okay? Corresponding set, yeah. So it should be only YXZ. That is the first sequence. The second one is, so it could be Z, Y, X. Okay, so just a different sequence or different arrangement. For the number 3, so it could be Y, Z, X. Okay, again, just a different sequence. So you can see we now have 3 different sequences corresponding to this set. So are we clear so far regarding with this string example?
Yes, sir.
Yes, sir.
Yes, sir.
All right. So we have here another string example. So from set, we have here sequence. Okay. So again, in set, since it should be only distinct and enclosed with curly bracket. then you have to follow the same as this one. So in here, you can have as many ones as you have, you can have as many twos as you have, but in set should be only one, and only one, two. Okay. And then we have here a sequence and then a set. Okay. Oops. Wherein everything is distinct, so you can just copy as it is and then just enclose it inside a curly bracket. Okay. And then the same with this one. This one is a sequence. And then we have here a set. Okay. So again, if you're going to transform those by string, so just remove the comma. Okay. And then we have here a symbol for no elements. So if you will, if you can still recall, the symbol for no elements in set operations in our past topics is a null set, okay, or just simply an empty set, okay. But for the string, the notion for this one is a lambda. Okay? I'm not sure if this one is really lambda, so correct me if I'm wrong. So this symbol is called lambda, okay, or just simply memorize the symbol. So once you see this one means no elements, okay. And then the same with this one. If you want to know the length of the characters or elements or string on that corresponding set or corresponding sequence, then it is represented by this one, okay, an absolute symbol. So this one is the same with our set operations before. So we call this one cardinality. Okay, cardinality of such sequence or such set. And then we have another one here is the, so this is just a variable. So it could be any variable. But what important here is the symbol asterisk. So if we have the symbol asterisk, this one denotes all the possible strings over that variable. Okay. And then if we have plus, this one denotes the set of all non-null strings over X. Okay. So when you say non-null, then just simply do not include this one. Okay. But if it's all strings, okay, then you have to include the empty set or no elements. Okay. All right. So since we don't have enough time anymore, so we will just continue the rest on the part 3. Okay. So it will, maybe this one will only take 5 minutes for the part 3. Okay. So I am ending this one now so that we can finish the remaining slides on the part 3. Okay. So see you guys on part 3.